From the beautiful studios of Way Happy, this is Mr. Meyer, and we are talking about series. What are we talking about? A series? A series like, hey, think about it. Friends, right? Friends was a great series. You added up all those episodes, and you had a series. Go figure. That's exactly what we're talking about in math. When you take a sequence and you add it all up, you get what we call a series. Now, there are finite series. Finite just means that the list of numbers eventually ends, right? Like the numbers 1 to 6. Or we have an infinite series, the numbers 1, 2, 3, 4, 5, 6, and continue on forever. That would be an infinite series. So we have those two different types of series, and you want to make sure that you understand which is which. And I don't think that's going to challenge you too much. But can you add up an infinite series? Usually not. Right? Usually it cannot be calculated, but in some cases it does converge, and we will get to those cases a little later. All right, first thing you want to know is sigma notation. That is right here. Math people have decided that sometimes it gets a little boring to write over and over this long list of numbers, right? And I wish there was an easier way. Well, there is sigma notation. It gives you an equation, right? Right here will be an equation, and that's how you create the numbers. And it'll tell you what number you plug in to start with. It'll tell you what number you plug in to end with, and that's how long your list is, right? So if n was 5, say, you'd have to plug in 1, 2, 3, 4, 5. Again, we're using integers when we count, so 1, 2, 3, 4, 5. And you would plug it into the equation, then you'd add them all up. That's all you'd have to do. So that is what sigma notation looks like. It scares people, but it's not a big deal, right? It's just how we would write a series. So if I look at the first example, they're asking me, look at this series of numbers, 1, 4, 9, 16, 25. You kind of want to get an idea of what they're doing. They added 3, then they added 5, then they added 7. Dang it, it's not arithmetic. Is there anything special about those numbers? Oh, wait. 4 is 2 squared, and 9 is 3 squared. I got it. So once you start to notice that this series is 1 squared plus 2 squared plus 3 squared. Notice those are nice integers. I can write that in sigma notation. I can say, hey, sigma, I need to add up u squareds, right? That could be or let's not use u because that's what they like to use in the form. Let's use k squareds. And the k's are going to go from 1 to, I don't know, if you have a set number, like if you wanted to stop right here and make this a finite series, you would say 5, or you just shrink the screen. You'd say 5. Or if you wanted to go on forever, you could say it goes on for infinity. Or in this case, since we're using n terms, I'm going to use n. I'm going to say go from 1 to n. So if n is 5, you'd put 5. If it's infinity, you'd put infinity. If it's 7, you put 7. And there you go. So I can now find that. Now look at part B. It says I want you to find the sum for 1 term, or 2 terms, or 3 terms, or 4 terms. So you have to fill that all in. And you can see it's pretty simple, like s sub 1 is equal to 1, right? But s sub 2 is equal to 1 plus 4, which is 5. And s sub 3 is equal to 1 plus 4 plus 9, which is equal to 14. And s sub 4 is equal to, I don't know, what's next? 14 plus 16 is 30. And s sub 5 is 55. And there you have your expansion of the sums. All right, what about the next one? Oh, my formatting got a little messed up. That is A, and this is B, apparently. Hopefully it printed out nicer than that. And it says expand and evaluate. So how am I going to do that? I am going to expand this out. Now you see I got to start with 1. So I like to make a little table usually and say like when K's got to go from 1, 2, 3, 4, 5, 6, 7. And I have to evaluate it in the formula k plus 1. So when I plug in a 1, I get 2, then I get a 3, then I get a 4, 5, 6, 7, and 8. And now I need to sum these all up, right? So there's a 10 and a 20 and a 35. So the sum is 35. And what about the next one? Ooh, from 1 to 5. So again, I'll do k goes from 1, 2, 3, 4, 5. So what is that? Well, it's got to be 1 over 2 to the k. So that would be a half, and a fourth, and an eighth, and a 16th, and a 32nd. Oh my goodness. When you add that all up, get a common denominator. I think it was 31 32nds. So that's what I'm going to put. but I trust you will try it. I think there is some properties that we would like to talk about. They say this: if you have the sum of two things added together, like think of that as the sum of like x squared plus x, you can actually break that apart as the sum of x squared plus the sum of x. If that helps you, do not feel worried about doing that, right? So that's what that first property is. Second property is kind of cool. If there is, say you have to do the sum of 5x squared, you could just do the sum of x squared and then multiply your answer by 5. So constants can come out front. And so that's kind of nice to know too, out of the front of the summation symbol. And right here, you look at this one. If you are just taking the sum of a constant, then you just multiply these numbers together. That would be something like the sum from 1 to 7 of the number 5. So you have 7 5s, you would add them up. You can just multiply 7 times 5. All right, let me ask you a question, and we will be right back. Nice job showing your work on all of those. All right, let's move on. There are some series that are arithmetic. Remember, we know what arithmetic sequence is. They're adding the same thing every time. So if I just change that sequence to a series by adding up all those numbers, not a big deal. So guess what? There is a formula, and we could talk about it, how Gauss created this formula in particular right here. We can talk about that in class, so make sure you ask me. But let's use it. All you need to know in this formula is how many terms there are in the list, which I think I can tell. And then I need to know, look at the notation here, the first term, but I also need to know the last term. If there's 10 terms, then I need to find U10. I have to know the last term. So you need the first and the last. Now remember, we also have a formula. Remember, UN equals A1 plus N minus 1 times D. Whoop, that means UN, U1. If I substitute this into there, I get this second formula. So that's why you see two formulas. It's just a quick substitution of one formula into another, the one from the previous lesson. So let's go ahead and try this, right? Example 1, it says, find the sum of 4, 7, 10, 15, all the way up. It went to 50 different terms. So good news. I have the first term. I can tell you the common difference. It is adding 3 every time. And so I'm feeling pretty good. Unfortunately, I do not know the 50th term. Now, I have a formula that could tell me the 50th term. I could plug that in and figure it out. Or I could just use the second formula, which I will choose to do. So the sum of the first 50 is equal to 50 terms over 2. Now I need 2 times the first term. So 2 times 4 plus n minus 1. Oops, I know n. It's 50. 50 minus 1. Times d, which is 3. So I got 25 is 50 over 2 times 8 plus, what is that, 49 times 3? Anyone know 49 times 3? I see 120 and I see 27, so 147. So 147, and then if I add that together and multiply by 25, I get 3875. And that is what all those terms would add up to. So if you add up that list of 50 terms, it would add up to 3875. And just want to show you your fancy calculator that you are loving also can do this quite well, especially the new ones. The way you get there, there's a shortcut key, but I'm going to use the long way. I'm going to hit math, and I'm going to go to, I believe it's 0. Yep, there it is, summation. And get ready to get your mind blown. It's going to have the summation symbol. So you need a variable. I'd say, all right, x is going to be my variable. It's got to go from 1 to 50. And then I have to put in the equation. Notice I just used a formula, so I need the equation of what creates this list. Well, this is just an arithmetic sequence. So that is the first term, 4, plus, now it would be n minus 1. So I'm going to do x minus 1 because that's my variable, times d, which is, I think, 3, so times 3. And if I hit enter, that will find the list, and it will add it up, and it'll get me 3875, and I will feel pretty darn good. All right, what about this one? Find the sum of this list. Now, bad news. They didn't tell me n. Oh, no, right? I need to know what n is. So I could figure it out. They did give me the first term. They did give me that it is adding 7 every time. Again, how did I figure that out? If you're not sure, take any term and subtract the one in front of it. So 8 minus 1 is 7, or 1 minus a negative 6 is 7. All right, so if I want to find that, I know the common difference is 7. That should have been a D, not an N. And I know the first term, U1, is negative 6. So I could tell you what term this is. 141 would have to be the first term, negative 6, plus n minus 1. I don't know n, but the common difference is 7. So I can say 141 equals negative 6 plus 7n minus 7, or 141 equals negative 13 plus 7n. 154 is equal to 7n, and then I can divide both these by 7, and I can get n is equal to, what is that, 22? I'm feeling 22. All right, and then now I can add that up. So they wanted the sum, but now I can finally use the formula. Good news, I can use that first formula. The sum of the first 22 terms is the number of terms, 22 over 2, times the first term. What did we say the first term was? Negative 6, plus the 22nd term, which is 141. Now I can say that is 11 times, what is that, 135? 135. And if I use my calculator, I get 1485, I believe. 1485. In fact, I can ask Sheila, because I do have a formula now, right? This is the formula that's creating the list of numbers. So if I do that, I would just go math 0. X goes from 1 to 22, we said. So 1 to 22. And the formula was negative 13 plus 7x. And it says it is 1485. Beautificent. Let me ask you a question, and we'll come back and talk geometric sequences next. Way to put in a solid effort on those problems. All right, let's talk about geometric series. So we know what a geometric sequence is, right? Where they're multiplying by the same number every time. So when you add that up, you're going to get what's called a geometric series. Sometimes on an infinite geometric series, you can add up maybe only the first couple. We call that partial sums. Maybe you don't want to add up all 20 numbers. You only want to add up the first 5. Why? Because they keep getting so small or so big that you're like, ugh, I'll just do a partial sum on this and kind of guess, right? So there are these things called partial sums that will be used, and if we are adding up all of them, then it is a geometric. So infinite geometric. A finite geometric sum, when r does not equal 1, is given by these formulas right here below. First term, and then you do r to the n. So you have to know how many terms are r minus 1 over r minus 1. That's funny because I do it backwards. I do the right equation, actually. There it is. 1 minus r to the n and 1 minus r. That one's more comfortable to me. So you'll probably see me using the right side. All right, find the sum of 2, 6, 18, 54. Hey, look, I recognized that it was geometric because if I wanted to figure out r, it would be 6 over 2, which is 3. But I could also do that with another term, 18 over 6, which is 3. So I'm like, okay, these are matching. This is geometric. Let's use the geometric sum. There's 12 terms. So the sum of the first 12 is equal to the first term, 2, times 1 minus r, which I discovered was 3, to the n power, we said 12 terms, all over 1 minus r, which we said is 3. So that is 2 times... what is that? Negative 2? Sorry, take that back. 1 minus 3 to the 12th is not negative 2 to the 12th. I got to figure out what that is. Over negative 2. And I'm just going to go straight to Sheila and let her calculate this for me. So alpha F1 fraction button is very nice here. If you don't have it, it's okay. Just make sure you put parentheses around everything. 1 minus 3 to the 12th. Oops, make sure you use the to the button. To the 12th, close that parenthesis and put it over negative 2. Make sure you use the negative, not the minus. And it says the answer is 53, what did I say? 1440, I believe, and that looks to check out. Again, I could use the summation button on our fancy calculator. I could go math 0, and I could say x goes from 1 to 12. I always miss that 1. From 1 to 12, and the equation that generates the numbers I already had. I did not have. I need to create real quick. Remember, the equation for geometric is the first term, which is 2, and then parentheses, what are they multiplying by? 3, to the n minus 1. All right, before I was rudely cut off, that answer should have been 531,440. Now, let's do the next one. And I know we're over 15 minutes, so cry about it. We got to find the formula for S sub n, and so there it is. I'm going to go ahead and use that same formula. I got the first term. I can figure out what R is. It looks like, if you're not sure, it looks like they're multiplying by negative 1/3, but I'm not sure, so I could do the second term divided by the first term, which is negative 1/3. I could do the third term divided by the second term, which is negative 1/3. It checks out. So I can see that we are definitely multiplying by negative 1/3. So if I want to find the nth formula, the sum of n terms, now they're not telling us n, so we're going to have to leave n in there. It will be the first term, which is 9, times 1 minus r, which is, what do we say, negative 1/3, to the n power, all over 1 minus a negative 1/3, or really 1 plus 1/3. All right, let's try to clean this up, and I'm not sure that it's going to look much cleaner. It is going to stay this because we don't know if n is positive or negative, so we don't know if that negative is going to disappear in there or not. And the bottom I see is 4/3, which then I can move the 3 through the magic of copy dot flip. Dividing by 4/3 is the same thing as multiplying by 3/4, correct? So that would give me 9 times 3 is 27, and then I have the 1 minus negative 1/3 to the n, all over 4, and that would be the equation for the nth term. Now, something kind of funny that we like to do here, that some of an infinite geometric series, it can actually, when n gets really, really big, look right here, when n gets really, really big, r to the n, if r is less than 1, would get really, really small. So you would just have 1 minus 0. So in essence, if r is less than 1, absolute value of r is less than 1, and n gets really, really big, then this kind of just turns into a 1, because 1 minus 0 is just 1, and you just get this formula of u1 over 1 minus r right here. So what does that mean? That means if you have a really large n, which means infinity, so that means the number in the list is infinitely long, and your r is less than 1, I should say the absolute value of r is less than 1, then you are able to solve this problem. So this formula can be used for infinite series. So again, if r value of a geometric series is greater than 1, it is said to be divergent, and you cannot add up that number because it just gets too darn big. However, if your r value is less than 1, it is said to be convergent, which I should have had written, and it can actually be summed up by this. And that turns out to be very helpful in many different things when we get into calculus, but it's very helpful right now as writing a number as a fraction. So how do you write 0.77777 as a fraction? Well, think of what this is. This is 7/10 plus 7/100 plus 7/1000 plus 7/10. Okay, you get the idea, right? Now, if I want to figure out that, we know what the first term is. We know what r is. They are multiplying by 1/10. So if I wanted to write this as a fraction, I could take the first term, 7/10, over 1 minus, in this case, 1/10. That's what they're multiplying by. That'd be 7/10 over 9/10. The tens through copy dot flip will cancel, and you will get 7/9, and that's how you can write a repeating decimal as a fraction. All right, have a great day, stay happy, and I'll see you tomorrow.